Here, let's find the index of a subgroup that is generated by mu sub 2 in the given group of D sub 4, which is already given to us by the scalars table here. So we are just going to first look for the elements, or count the number of elements on the group and its equivalent in the corresponding subgroup generated by mu sub 2 before we can solve for the index. So for D sub 4, D sub 4 is the collection of all the permutations on a set with 4 elements. So we have the rows here, the mu's, and the deltas. The rows, we have the row sub 0, row sub 1, row sub 2, and row sub 3 are rotations. We have mu sub 1, mu sub 2 are the reflections against a perpendicular bisector of each side. And we also have here delta sub 1 and delta sub 2, which are actually the reflection when we flip our rectangle as a representation of D sub 4 or on its diagonals. So we have 8 all in all, 8 elements or 8 permutations on D sub 4. Now, for our subgroup, which is generated by mu sub 2, so we'll be using the scalars table as we are going to look for the elements for this. So that means we simply operate our mu sub 2 to itself, and whatever be the result, operate it again to mu sub 2, and so on and so forth. So we'll start with mu sub 2 here. This is our mu sub 2, and our mu sub 2 is here. So when we operate mu sub 2 and mu sub 2, we will get row sub 0. This is our first element on this subgroup, row sub 0. Then let us try to operate row sub 0 against the same element mu sub 2. So row sub 0, and then to be operated with mu sub 2, you will have here mu sub 2. That's our second result. Sorry, I'm not yet closing this because there might be additional. But of course, since we return to mu sub 2, and we will just return to this here, mu sub 2, which is row sub 0, that means we close that. Because there are only 2 elements or 2 permutations on the subgroup that is actually generated by mu sub 2. Now with this 2 already identified, let us now proceed to the index. Okay, so we have here the index. Let's label this H and D sub 4 being our G, because general form of this is index of, we have H in G. Or using these notations, you have index of the subgroup generated by mu sub 2 in our D sub 4. This is further represented by this notation. This means the index of H in G. The index of H and G is actually just the ratio of their orders, making our G here, which is D sub 4, and our denominator being the subgroup generated by mu sub 2. So for the order of D sub 4, that means number of permutations that can be found on D sub 4, 1, 2, 3, 4, 5, 6, 7, and 8. So you have 8 here over. For our subgroup generated by mu sub 2, we have 2 elements, row sub 0 and mu sub 2, so 2. In short, the index of H and G, or more specifically, the index of the subgroup generated by mu sub 2 in D sub 4 is equal to 4. This is what this video is looking for. But just to connect this on the next or the previous concepts, this index is actually also the number of cosets for both sides. This would mean that if we are going to continue showing the cosets of the subgroup generated by mu sub 2 in D sub 4, we would expect 4 right cosets and 4 left cosets, because there must be same number of cosets, 4 left and 4 right cosets. Okay, so as to what are these cosets, it's not captured by this specific video, but that is actually the hint on determining the number of cosets. So this is how we show the index of the subgroup generated by mu sub 2 in the group D sub 4 using this formula. Thank you very much for watching.